Okay, so good morning everyone. Today I'm going to be showing you how you're going to solve um, gravimetric problems in analytical chemistry using only your calculator with minimal amount of solving done on paper. So I'm going to be showing you like a very simple trick and a very simple workaround on this one. So we have example number 8 over here. It says a 0.2356 gram sample containing a sodium chloride and barium chloride yielded 0.4637 grams of dried silver chloride. So we need to calculate the percent of each halogen compound in the sample. So we have the answer over here, but how are we going to solve that one using just a calculator? So we'll put this one, and then if you have your own calculator, you can go to mode. Usually it's present in all Casio and also Canon calculators as far as I'm concerned. So you need to press mode so that you need to go before you need to go into an equation mode muna so that you can solve this one. So you need to click mode and you look for equation. So since equation is number 5, we'll press number 5. Since we have two unknowns here, we'll just use number 1. So two unknowns, which is a set of two equations. So this is a simultaneous na mga linear equations, and this can be easily done using a calculator. So let's press number 1. So you can see here that there's already a matrix that you can just plug in all of the values. So since we're looking for just NaCl and BaCl2, we can, I think it's already ano na, can already given, and it's also obvious that you need to assign an x and a y. So let x be NaCl and let y be BaCl2. So let's plug this one in. So it's just going to be 1 because x is equal to 1 and y is equal to 1. And then another 1 for y. And then here we're going to plug in the mass of our sample, or this one rather, the mass of our total sample, original sample, which is 0.2356. Just press the equal sign. Now we're on the second line of the equation already. This is where we're going to put the gravimetric equation. So at the same time here, you still need to balance the equation or balance the amount of coefficients, especially if your target is the is your chloride. So we'll have a workaround on that one. So first, here's the AgCl and ang kaning NaCl na to na na relationship. Now since na may x diri and y diri we already know that the gravimetric factor is uh the amount of the weight, the molar mass of the of the salt chemical over the molar mass of the weighed chemical. Now, mabaliktad ni siya because we need to put the AgCl first because we already know na nananga to ang NaCl diri So we'll just input 143.32 divided by 58.44. And then since the chlorides are balanced, we don't have to multiply an additional coefficient anymore. So I'll just press equals. Next is for the BaCl2, which is not balanced. So since AgCl only has one chloride ion, whereas BaCl2 has two, we need to add a 2 na coefficient sa atong AgCl. So 143.32 times 2 divided by 208.23, and then we press the equal sign, and then since ibutang sa nato diri ang what do you call this one, ang amount or ang yielded na na mass after the transformation into dried AgCl, which is 0.4637. So since our equation is already set up, we'll just press the equal sign once more. So for the value of x, which is NaCl, we'll write down 0.129. So please write that down if you have your pens with you, 1296. And then for y, we have a value of 0.10604. Now, we're going to get the percentages of each respective compound. So, we'll just get another calculator on our side, and then i-input lang nato. So, the amount of sample of NaCl, which is what? 0.1296 divided by 0.2356. So, ang atong answer is 55.008, which is, or 001, which corresponds with the answer that is given on your handout. Next is our BACL. So 0. Oops. 0.1069 604 divided by 0.2356, yielding us 44.99 or 45%. So that's just how it is for a basic example such as this one. On the next example, I'm going to be teaching you on, it's still going to be the same setup as this one. Okay, everyone, so let's continue our discussion with gravimetry and also the setting up of simultaneous linear equations. So before I start on number 9, just a small tip for everyone, especially when reading and also analyzing problems such as this one. I think it's very important to note that you'll only ever have to like take into consideration these types of elements, or like, I mean these types of components in your problem, components that are kanang quantified or quantifiable, so that dili mo maglibog, there isn't going to be any more what do you call this one, confusion as to how you're going to approach the problem, especially that sometimes problems like these have the tendency to confuse people na, especially with this section here na, the products CO2 H2 HCl were passed through a solution of sodium bicarbonate, blah blah blah, so on and so forth. So I think it's a universal experience, especially for people who are taking this course for the first time, to be confused with these types of problems because there are a lot of things happening all at once. But I think it's very important to just look at these components here. So like just a good rule of thumb, only look at those components na naay unit na na grams, or na siya given na molar mass, and then na siya mga questions, or kanang it explicitly specifies what you need to do or what you need to find for. Because if magi pa kadiri sa kun times on, I had this tendency to like include this one in equations, but during my review for board exams, thankfully I was able to overcome that type of mannerism. So let's continue with this one. So mode setup, press 5 for equations, and then press 1 because we only have 2 unknowns here, still the same as the previous problem. So we'll just set up the equations over here. Okay, so a 0.2795 gram sample of an organic mixture containing hexachlorobenzene, and this one was burned, and then it was acidified, and then it yielded 0.7161 grams of silver chloride. So we need to calculate each percentage of the halogen compound in the sample. How are you going to do that? So again, let x and let y gap mata diri. So let x be our hexachlorobenzene, and let y be this one. So it's just going to be 1 plus 1. And then the mass of our sample, which is for our original sample, which is 2795. 0.2795. Okay. So for 2, this is just going to be set up the same way as earlier, how you're going to set up your gravimetric equation. So number 1, sa nga tong x diri is with respect to hexachlorobenzene, And then since hexachlorobenzene is already here, the gravimetric factor is shifted from same as earlier gyapon as instead of molar mass of weight is sought over weight, it's going to be weight over sought. So AgCl ang mauna. So 143.32. But we need to balance this one because our AgCl only has one chloride ion, whereas our hexachlorobenzene has 6 chloride ions. So we need to multiply that one with 6. And then we divide it with the molar mass of this one, which is 290.83. And then press equal sign. And then the same story goes for this one as well. So AgCl, which is 143.32 times 5 chlorides, because this organic compound here has 5 chlorides. We have 1, so we need to balance that 1. Divided by the molar mass, which is 354.49. Then equal sign, and then we put the yielded amount of the AgCl here, which is 0.7161. So since the equation is already now set up, we just press the equal sign once more and we'll just wait for x to arrive. So the value of x is 0.1615, and if we're going to divide this one with the value of our sample, which is 0.2795, 1615 over 2795 times 100 is equals to 57.65%, or near that one, because we used a value of 143.32 instead of 0.22. Same goes for y. Our y value is 0.11795, and then we divide it this one by 0.2795, multiply that one with 100, and then the answer is going to be 43.24, or along those lines. So hopefully it's clear for you guys na, and I also hope that at the same time you have your pens and papers with you at the moment. So let's try the next problem, which is number 12, which is kind of tricky, I would say, but we'll work our way through it, I guess. So number 12 says that there is a sample containing sodium chloride, sodium bromide, and inert materials which weighs a total of 1 gram. So what do you mean by inert materials? Inert materials means materials that do not react or do not participate in a reaction, or I mean inert, which is like chemically non-reactive, basically lang. So the sample is reacted with silver nitrate, and it gives a precipitate of silver chloride and silver bromide, which weighs 0.5260 grams. Now, by heating the precipitate in a current of chlorine gas, the silver bromide is converted into silver chloride, and the resulting precipitate then weighs 0.4260 grams. So we need to find the percent NaCl and the percent sodium bromide that was present in the original sample. So how do we do this one? Now, the first thing that we need to realize here is that this is not the same situation as previously. Now, you can just let x let y for NaCl and NaBr. That's not how it is, because the first part of our story here already involves the production of silver chloride and silver bromide, which is derived from the NaCl and NaBr. Gets? So what happens here is that we need to get the gravimetric factor with the relationship of AgCl and NaCl and AgBr and NaBr. At the same time, we also need to already assume na there is already a sodium here, so it's just going to be set the same way as the previous problems. So 143.32 divided by the molar mass of NaCl, which is 58.44. Then we press equals, and then for NaBr, which is which is ano AGBR over NEBR. So 143.32, oops, divided by the molar mass of NEBR, which is 102.79. And then we plug in here the value of the sample that was after the first precipitation, which is 0.5260 grams. Okay. For the next part of our equation, we can see here that the AGBR in the first part of the story is converted into AGCL. So what it means here is that by the second step, or after the second step, you're only going to have ano just a silver chloride na precipitate. Wala na kay lain na sagol pa, which equates to 0.4260 grams. Now, how are we going to do that then? Now, the story is still the same as the first part. You need to get the what do you call this one? You still need to get the relationship with your AGCL and your NEBR. Only this time that you need to get the relationship with your AGCL and your NEBR. Okay? So 143.32 divided by 58.44. And then still the same, 143.32 divided by the molar mass of NEBR na dayon, 102.79. So after plugging that in, we need to add we need to also plug in the resultant precipitate, which is 0.4260 grams. Okay. So now that this is already complete, we just need to again continue pressing the equal sign. It says no solution. Okay, how do we do this? For a while, I think there's a mistake. For a while. I believe this is... Sorry, this has to be 187 rather. 77 divided by 102.79. Sorry, nalipat lang ako ganina. So this is for your part 2 here. Then equal sign. Okay. So, we'll just have to divide this one with, with this part over here with 1 gram. So, 0.042 over 1, which equates to 4.23%, which corresponds well with what is shown in the calculator. Next is this one. So, just add this one, divide this one with 1 gram times 100. We get a value of 23.14%. So I hope that's clear and very straightforward, and there isn't actually like a lot of handwriting or solution writing that's going to happen. Though I still recommend writing down the equation while also doing the calculations on your calculator as well, because sometimes setting up equations can be very tricky, and at the same time maglibog na kaon sa ang next. So it would help if you're just going to be able to just use your calculator and then plug things through, and hopefully like the succeeding hopefully the succeeding instructions are clear enough for you guys to understand. So yeah, this is like very simple lang na na arithmetic. Masundan naman nimo siya. And if you have any questions, you can just send me a message or something. So I hope you guys are gonna ace the exam later on, and then I hope that we get to see each other very very soon. Bye bye.